Hello and welcome back to module number 10, and we are going a little bit backwards in order for us to understand uh, the articles and the chapters that we read about time series, and I'm going to add trends in order for us to apply it to visual analytics or visual analysis. A simple example of time series and visualization is the ability to capture time in one aspect, but also to add additional dimension in order for us to show what it is all about. So in this case, we are able to see forecast starting date and see the points, and there is another layer which is the color to portray or give another dimension to it. When we are talking about time series in the context of analytics, we usually talk about the description of the data. We also discuss the interpretation, the forecast, the control, and usually, when we are talking about statistical analysis, we are talking about hypothesis testing and the ability to convert those things into visual analytics. An example: Apple stock market, and usually it is a good stock, and see how they can be portrayed. And again, layers of colors can be displayed in order for us to add more information about the stock market and how it been examined through the time. So we have the idea of transform data. We are taking one dimension and we are displaying it as it is. Again, this is one-to-one. It doesn't require a lot of design aspect to this transformation. But when we are talking about trend, and in time series we are talking a lot about trends, this is where we are in visualization can be displayed, important part of how we report on time series analysis. And again, a simple line, a straight line in this case, can give another dimension to the data that we are often lack of understanding when we are reading it as a word paragraph. And again, the issue of what it is and how it's been displayed, visualization is quite key on it. And again, the power of visualization is the ability to add additional dimension to the analysis. And one of the things that we need to talk about, the trends and seasonal changes, and again, the use of another dimension, another graphic element into the design itself can give us those dimensions instead of writing another paragraph or to describe the analysis in another essay. It's sometimes really hard. In this case, the visualization capture that in one take and able to provide us more in-depth about that. The objective of time series analysis often entail the idea of a formula that usually provide all the components of the analysis and the data that we need to gather in order for us to do that, the interpretation, the forecast, and as I said, as I lay out for you all the components. We also, in statistics, we also have time series module, and it is the idea that we can have a joint distribution of sequence and with random variable in order for us to display an idea of displaying how the data is being distributed in three or two dimensions and how it been displayed. And so the example, white noise, uncorrelated, and idea of adding those dimensions can add to the idea of in-depth analysis of the data itself. And what else is the idea that the time series module also entail the idea of forecast. I can forecast, for example, if I had the data from Apple, I can be able to use this formula to forecast what will happen in the next 6 months. But again, the forecast is based on past, so it doesn't is not 100% guarantee that this will happen. So again, white noise, an idea of what it means and how to apply to it. And again, this is example of time series and how it's been displayed in order for us to tell a story. Random walk is again the issue of it's a whole chapter in statistics about what is a random walk, and it's about the differences that shows about the ST and ST minus 1, and the idea of that we have a capture of it in a formula that allowed us to predict what will happen. But again, as I said before, the issue of visualization or the idea of adding dimension as a visualization with colors, with the location of the trend, give us the ability to tell us a more in-depth story to the analysis that we conducted and provide us more ideas of it. I just capture some of those modules. I'm not expecting you to run those modules and conduct an analysis, but it's a good point of reference that I want you to have in your mind when you are starting to analyze the data. You can use basic statistics, you can use more aggressive or more advanced statistics, and in this case it's a formula that can be used in order for us to capture trends in the data in order for us to better understand and the output of it with that regard. So this is part of the idea, this is part of the time series module. And again, I did not go over the module itself. I did not break it down to components. I don't think this is the main objective. The main objective for me in this class is to show you the ability or the transformation of it to visualization. So we can talk about the estimation, we can talk about the differences or nonlinear transformation, and is it fit the module with that regard. So again, I can show you example by each scale or each aspect of those modules with regard for nonlinear transformation, how it can be done, and there's a lot of papers on the subject, differences with regard to how it's been displayed and how it's been captured and analyzed, and the idea of the differences and the trends and the ideas, what it is consists of. And again, just to give you some sense that we are trying to be as coherent with regard to our analysis when we are converting it to a visualization. So all of it is part of the time series module, and this is part of the terminology that they use and what it consists of and how it's been applied. And again, those are part of what we can see out of the data with regard to proportion, with regard to the formula that we use and how it can be applied, and the issue of what do we play, what do we provide in order for us to demonstrate what we have found. So example, and again I will go over briefly on the R code with that regard. It defines the X1 is under Armenia.slim, and we are listing a data set from 1, 0, and 0, and we are trying to have 100 cases. The same goes to x2 and the same portion in this case, but in this case, it is with the minus 0.9 compared to x1, which is 0.9. And we are plotting it in order for us to display it. And the issue is how we apply it and stimulate that in order for us to display it. So this is again the example of the visualization and the ability to capture it and be able to display it. But we also need to look at that from historical point of view. What is the history taught us? And we will look at over time visualization, and we'll look in the end. We're going to look at RStudio and time series in that regard. So this is the historical part of time series, and one of the biggest visualization well recognized is the work by Charles Joseph Mignard. What he tried to do is, if you are a historian, you probably remember that Napoleon tried to capture Russia, and he tried his campaign against Russia started in the fall, where if you are familiar with Russia weather, fall is not a good time to visit Russia. But he did not thought about that, and he started this pursuit after Moscow in the midst of winter, a harsh, cold winter. And in the beginning, you will see where the line started. You see two colors, brown and black, and black is the escape of the French army back to Paris, which you see in the beginning they had a larger army, larger groups, and in the end, when they started to escape the winter and escape the battle, they came back with less soldiers and less support, and as a result they lost the fight. So this is a good capture and considered to be one of the best visualization with that regard. So Napoleon 1812 started this campaign on Russia. Mignard created this. He was basically engineer, and he tried to input data based on the size of the army. And in the beginning of the campaign, it was a larger set. In the end of the campaign, a lot of soldiers died, and he provided us the location of 2 dimensions. And I will talk about dimension in the next slide. Then he gave us, in this visualization, he gave us the army movement, the temperature, which was a big effect on the end result, and the time. How long did it take Napoleon to try to walk to Moscow, and how long it took him to come back? So again, the issue of looking at dimensions, looking at that will give you a better sense of how complex this visualization is and how dense it is. The issue of dimension is a really interesting subject that's been discussed quite a lot in the literature. Dimension is the idea that you can add dimension to the analysis itself or to the data itself in order for us to show the connections and one affect the other. And so in this case, we can apply dimensions to show the idea of it. In Mignard, the dimension is not only with the graph of the size of the army, but the dimension is also the size of the time, the temperature, and everything else that he captured in that. So it's considered to be one of the best graphic ever produced. Points all the data corresponded to 6 input variables. So it clearly shows the message underlying the input data. And it provides data that is really, in a sense, quite complex. Taft which we will talk about his work and we will learn about his insight about the history of infographics and visualization, provide us a more insight to Mignard's infographics. And we will see his work. We will talk what Taft brought into the visualization world and how we can implement that. And of course, because your professor is a little bit obsessed with R, here is an example of Andrew Hens that used ggplot2 to create Mignard graph. It's a little bit complex. It's not one click, and you get out of it as the Mignard diagram, but it's a nice try and a nice attempt to use the R in order for us to display it. Based on a textbook, Visualize This, what we're looking over time series is trends. And so those trends can be displayed as points, and we can look at that in RStudio and time series. So what is trends? It is the idea of recognize that any time series may have the following 4 components: trends component, seasonal component, circle component, and irregular components. And those are part of how we see the time series. So the trend component, it's a long run increase or decrease over time. It's usually data taking a long period of time, and it provides us an idea of linear or non-linear of the growth of the data. The purpose of visualization in time series is to detect and validate the properties of unknown function f. So those are the part of the things that we often use in that sense with that regard. And I lost it. Sorry. So the idea of how we are looking at that and what is the patterns on it. One of the things that is really important for me, and this is part of every visual person will talk to you about it, what is the best practice? And I broke it down to dot plot, line graph, bar chart, star graph, clock graph. All of that has the idea. And the issue is that I want you to look at the data density issue that entail on it. And so, example, the clock is color blending, which might be difficult or too small of areas and it's not very clear. Those are components that we need to be aware and maybe to come up with the ideas how to solve it better or how to implement better in order for us to have better success in our visual storytelling or visual analytics. That's it for now. Oh, sorry. Of course. And I need to show you the idea of RStudio to capture time series from the design aspect of the table, each design patterns, and its uniqueness problematic aspect. In this class, I will focus more on the design those time series in R. So this is part 1 of my lecture. In part 2, I will continue the idea of the RStudio. Until next session, bye for now.